The Earth is a water planet, but global water resources are under attack. From dead zones to overfishing, rising seas to plastic pollution, our water planet is changing in ways that threaten us all. The good news is solutions exist, and EarthEcho is on a mission to find them. I'm Philippe Cousteau. Our fisheries are on the verge of collapse around the world. Join me as we explore solutions to restoring them to sustainability. On EarthEcho Expeditions, What's the Catch? Our consumption of seafood has more than doubled in the last 50 years. As the world's population continues to expand, we need to recognize we can't keep fishing the same way we've done in the past. It's simply not sustainable. To understand threats to our fisheries and how we can manage them better in the future, the EarthEcho Expedition team has come to the coastal city of Plymouth in the United Kingdom. Since the 1300s, fishing has played a major part in the growth of Plymouth, and today it stands as one of Europe's largest seafood exporters. As we dive into our expedition here in the UK, we'll start things off by heading out on the water to explore the deep-rooted history of fishing here in Plymouth. I'm climbing aboard a research vessel at the University of Plymouth to meet up with Dr. Martin Attrill.
You're here in one of the biggest fishing ports left in the UK, because obviously you've got these lovely clean waters out here and access to the Atlantic.
In order to determine the health of fisheries and manage their future, we need to collect data that's current and compare it to the past.
So if you shift your baseline back to 1970, you can see that the amount of cod that there were in the North Sea was massive compared with where we are now.
And one way Martin will do this is by using a trawl.
This is one piece of kit we still use, but there are alternatives. And they've been doing a beam trawl survey like this for decades. If you change the methodology, you lose the data.
You make a really good point, Martin, about the importance of consistent data over time.
Yes.
You know, having these baselines of information is critical, and maintaining the investment in that science over time is
absolutely
important.
We'll drop the beam trawl into an area that Martin knows doesn't have any reef or rock habitat.
I'm so excited, this is terrific.
After 10 minutes, the trawl is pulled up and we get a look at the different species living below.
Check this out.
These big spider crabs, so it looks like it's tangled, but these things allow seaweeds to grow on them as some sort of disguise.
We'll separate the animals into trays filled with seawater.
We've already got easily a dozen different things. I see some shrimp, I see various different types of fish.
And record what we found before releasing them.
Martin, what do trawls like this tell us about the health of this area?
Firstly, it can tell you what's living on the seabed and is there the sort of type of thing which you would expect. You can obviously get some idea of how many young fish you've got in an area. And if you do this using the same technique, the same sort of area every year, you can then build up this long-term picture of how things are changing.
Like any animal, fish need an ample amount of food to thrive. And the key to that is ensuring that the entire food web that supports them is healthy and sustainable. At the University of Plymouth, Dr. Abigail McWatters-Gallup studies organisms that, while they're virtually impossible to see, are still critical to healthy fisheries.
In a nutshell, what is plankton?
So plankton are microscopic animals and algae. It's the base of the entire marine food web and marine ecosystem.
And
without plankton, we couldn't breathe, we wouldn't have anything to eat, and we wouldn't have a marine environment like we have now. Like land plants, the algae make oxygen that we breathe, so plankton make half of the world's oxygen. And lots of organisms that we have in the sea start out their lives as plankton. These mussels, for example. They start their lives as plankton.
These hard-shelled organisms start as little tiny microscopic animals floating around in the ocean.
That's right.
Earlier, on the research vessel with Martin, we cast out 2 small nets to collect plankton to bring back to the lab.
How many bits of plankton do you think?
Oh, I bet there's millions in there.
Using a simple microscope, we unveil a world of life within just a few ounces of seawater.
So you can see everything moving, right?
Yeah, it's all sorts of stuff. It's just
the more you look, the more you see.
Oh, that looks like a shrimp with
That-
2 eyes. Am I right?
Yep, that is a shrimp.
Okay, and we've got, what else have we got in here?
That's a copepod right there.
A copepod.
Fish eat them, and they eat the phytoplankton, so they're that kind of link between phytoplankton and fish. This is the marine food web on a wall.
Why do we say food web as opposed to food chain?
Well, you just gave a great example. So the shrimp might eat the copepod, but a fish might eat the larval shrimp or the copepod. So it's not just a chain that goes first link, second link, third link, but different things at all different levels are all eating each other.
So you remove some sort of planktonic organisms, maybe because of climate change or pollution, whatever it may be. It can have this knockoff effect on dozens and dozens of other creatures in this complex web.
Yep, that's exactly right.
Complex food webs can help fisheries be more resilient to natural stressors. But as we'll see next, the balance is incredibly delicate when facing an onslaught of challenges like climate change, overfishing, and coastal development. To learn more about ways to keep our fisheries sustainable and find out how you can take action to make a positive difference in your community, visit EarthEcho International at earthecho.org. EarthEcho Expedition is sponsored by the Northrop Grumman Foundation. Northrop Grumman is a leading global security company dedicated to increasing STEM education opportunities for students and the teachers who inspire them.